I'm going to be explaining number 12. Number 12 says, three charges are arranged as shown in figure P15.12. Find the magnitude and direction of the electrostatic force on the 6 nanocoulomb charge. So I redrew this diagram right here using 1, 2, and 3 to signify them for later. This one's the 6 nanocoulomb charge, this one's 3, and that one's 2. They're each, these are 0.5 meters apart. And from the y-axis, this one's 0.5 meters apart. Keep in mind that 1 nanocoulomb equals 1.0 times 10 to the negative 9 coulombs. And since these are each the same length, 0.5 meters and 0.5 meters, this can simulate as a 45, 45, 90 degree triangle, which will be used to figure out the distances that each of these charges are from each other, which will be 0.5 times the root 2 meters. And this is for the distance between 1 and 2, and this is a triangle between 1 and 3, because 1 and 3 looks like that. It's a little triangle between that, and 2 and 1's that. And now this is the force between the first and the second charge, and you plug it into the Coulomb's law formula, with K being the constant of 9.0 times 10 to the negative 9 newtons meters squared over Coulomb squared, times 6 times 10 to the negative 9 coulombs, times 3 times 10 to the negative 9 coulombs, over the square of 0.5 root 2 meters. Putting that in the calculator, you get about 3.24 times 10 to the negative 7 newtons. And you do the same thing to figure out the force between the first and the third charges, and using the same formula, except this one's now 2, because the third charge is 2 nanocoulombs versus the second one being 3 nanocoulombs. You get 2.16 times 10 to the negative 7 newtons. Now, okay, we got these forces, but we don't really know which direction we're exactly heading, except that all these charges are the same, in the sense they're all positive, so they'll each repel each other. So from this charge will go out this way in terms of the third one, while this third one repels the other way. So as this one goes out that way, the other one goes that way. And from the second charge, this one will go out exactly opposite from each other. And they'll go out in terms of 45 degrees below the x-axis here and 45 degrees above the x-axis here. Now that we know kind of the direction of where they're going, we need to split in order to figure out the result of these two different directions. We need to put these in terms of vectors, and by doing that, we can figure out the parts of the vector that's going out for both of them. And since this is a 45 degree triangle, you can use the same thing we did earlier, except now this is the hypotenuse. You divide it by root 2 in order to get the length of each of these parts of this vector. So 2.16 times 10 to the negative 7 newtons over root 2, which is about 1.53 times 10 to the negative 7th. So that's the two parts for each of those. They'll both be 1.53 times 10 to the negative 7th. And doing the same thing for the first repelling away from the second particle, it'll be 3.24 times 10 to the negative 7th over root 2, which will be about 2.29 times 10 to the negative 7th. Using these, we can write it in terms of two vectors. The vector of the first particle repelling away from the second particle will be 2.29 times 10 to the negative 7th, the x direction. And then the y direction is negative 2.29 times 10 to the negative 7th, because this one's repelling down with respect to the x-axis in the original diagram, is y and x. And then for the vector of the first charge repelling away from the third one will be 1.53 times 10 to the negative 7th in the x and y directions. And to get the resultant vector, all we gotta do is just add up the x components and the y components of each, which will be 3.82 times 10 to the negative 7th and negative 0.76 times 10 to the negative 7th. Now with that, we have the two directions of both these vectors. It'll look something like this: out 3.82 times 10 to the negative 7 newtons, and then down 0.76 times 10 to the negative 7 newtons. Now that we have the parts of the vector, we can basically just find the hypotenuse using Pythagorean's theorem, which will also give us the magnitude of the vector. So the square root of 3.82 times 10 to the negative 7 newtons squared plus negative 0.76 times 10 to the negative 7 newtons squared, that thing all over square root, we'll get 3.89 times 10 to the negative 7 newtons, which is the magnitude of this. And we can find the direction by solving for theta, and tangent is equal to opposite over adjacent. So the inverse of the tangent will get us the angle. So you plug in the two parts of the directions, negative 0.76 times 10 to the negative 7th over 3.82 times 10 to the negative 7th, get an angle of theta equals negative 11.25 degrees. This just means that it is 11.25 degrees below the x-axis, and that is our final answer.